13.8 billion years ago, before the first star was born, before galaxies spiraled into their elegant shapes, the universe was a black ocean of pure potential. No light, no color, no landmarks, just a cosmic fog of particles so hot and dense that photons, the very messengers of light, were trapped, endlessly scattering like whispers in a crowded room. Time itself had barely taken its first steps, and yet, the seeds of everything, every planet, every star, every breath you've ever taken, were already there, hidden in that blinding chaos. But then, something changed. About 380,000 years after the Big Bang, the universe cooled enough for the first atoms to form. Electrons found their partners in protons, and in that instant, the fog began to lift. For the first time, light was free to travel, stretching across the newborn cosmos, carrying with it the first true image of the universe's face. This wasn't just any light. It was the light, the oldest photograph in existence, etched across the sky in a faint microwave glow we can still detect today. And if you could stand there in that moment, suspended in the silence after the birth cry of creation, you'd see a universe unlike anything we know now. A soft, endless haze of orange and red, the afterglow of everything that was and everything that would be. That light, the cosmic microwave background, is the universe's baby picture, and decoding it is like holding the diary of creation itself. But what did this first light really reveal? And how did it shape the path from chaos to cosmic order? The answers lie in a journey that will take us from the fiery furnace of the Big Bang to the slow blossoming of the first galaxies. As the universe expanded, that first light stretched, its wavelengths lengthening with every passing eon, cooling from a fierce white-hot blaze to a soft, whispering glow detectable only in the microwave. Imagine a sky where no stars punctuate the darkness, only a gentle, uniform radiance bathing a newborn cosmos. That is what the first atoms saw. But light alone did not craft the universe's tapestry. Gravity began its invisible artistry, tugging at tiny fluctuations in density, pulling some regions slightly closer together, leaving others emptier, shaping the skeleton of all that would come. Within these subtle ripples, the seeds of galaxies, clusters, and superclusters were sown. The cosmic blueprint embedded in patterns too delicate to notice without a telescope trained for patience and precision. Slowly, hydrogen and helium clouds began to collapse under their own weight, igniting the first fires of nuclear fusion, birthing the earliest stars. These were not the graceful, long-lived stars we see in our night sky today. These were titanic giants, burning furiously, living briefly, and dying spectacularly, scattering the universe with the first heavy elements. Each explosion, each flicker of light, was a note in a symphony of creation, composing the very chemistry of life to come. And all of this, the stars, the explosions, the formation of galaxies, was orchestrated against the backdrop of that primordial glow, a silent witness to the universe's slow awakening. It is within these early moments that we can trace the story of light itself, traveling across billions of years, whispering the secrets of beginnings, of a cosmos emerging from nothing into everything we now strive to understand. But even as these first stars ignited, they raised profound questions. How did the first galaxies assemble? And why did some regions remain barren, shadowed in silence while others blazed with creation? The answers lie in the vast, interwoven dance of matter and energy, where each cosmic dawn writes a chapter in a story still unfolding. As the first stars blazed into existence, they transformed the universe from a dark, silent expanse into a theater of light and fire, each ignition a beacon cutting through the cosmic fog. These primordial stars, often hundreds of times the mass of our sun, burned with a brilliance so intense that they altered the very chemistry of space, forging elements heavier than hydrogen and helium in their cores and seeding the cosmos with the raw material for planets, oceans, and eventually life. But the story of light was not just about stars. It was about space itself awakening. Photons, once trapped and diffused in the opaque early universe, now streamed freely, illuminating pockets of gas, tracing filaments, and revealing the intricate web of matter that gravity had spun. These filaments stretched like glowing threads across an otherwise dark void, connecting clumps of gas that would coalesce into the first galaxies. Imagine traveling through this universe. You would see islands of brilliant star clusters floating in a dark ocean, their radiance punctuating the void, each galaxy a nursery of light shaping the surrounding darkness. And yet, even as these first structures emerged, the universe was far from calm. Ultraviolet radiation from these first stars tore apart hydrogen atoms in a dramatic event known as reionization, transforming the cosmic landscape and allowing light to travel farther than ever before. It was a turbulent awakening, violent yet beautiful, chaos woven with order, darkness pierced by fire, a dance between creation and destruction that set the stage for everything to come. This epoch was not only the first illumination but also the first cosmic story, one written in light and shadow, revealing the universe as a living, evolving entity. But even as light spread and galaxies took shape, mysteries remained. Why did some regions form stars quickly while others lagged behind? And how did these first luminous giants influence the formation of the universe's vast, intricate structures that we see today? The answers lie hidden in the interplay between gravity, radiation, and the lingering whispers of that first, primordial glow. As galaxies emerged from the cosmic fog, their shapes still raw and untamed, the universe became a sprawling gallery of light and matter, each structure telling a story of gravity's patient sculpting. Imagine swirling clouds of hydrogen and helium collapsing under invisible hands, twisting into disks, spirals, and irregular forms, while the first supernovae scattered heavier elements like cosmic paint across the void. These explosions were not mere flashes. They were messages, broadcasting energy and material across unimaginable distances, enriching neighboring clouds, and triggering new waves of star formation. In these nascent galaxies, star clusters glimmered like scattered jewels, some shining steadily, others flickering and dying in spectacular bursts. The light from these early stars traveled for billions of years, stretching and cooling, carrying with it the history of the universe's first million-fold leaps in size. Yet, even as this grand cosmic ballet unfolded, the universe was still governed by invisible forces. Dark matter provided the unseen scaffolding upon which galaxies clung, guiding their formation and motion, while dark energy pushed the cosmos outward, accelerating expansion and shaping the ultimate fate of every light-emitting particle. Visualize a vast, three-dimensional web of luminous filaments and shadowy voids, where light threads the needle between structure and emptiness, painting a portrait of a universe both chaotic and harmonious. And within this immense tapestry, every photon is a storyteller, every star a narrator, recounting the saga of creation in wavelengths that our telescopes can decipher only now. But the story does not end with the first galaxies. It continues in the intricate dance of collisions, mergers, and the relentless birth and death of stars, echoing the first light's message across the eons. The universe, once silent and opaque, had become a resonant symphony, and every note was encoded in light, the very light that had first escaped the primordial fog. By the time the first galaxies had fully emerged, the universe was no longer a blank canvas but a living, breathing mosaic of light, matter, and motion, each galaxy a testament to billions of years of evolution and cosmic interplay. Light, once trapped and diffused, now traveled across unimaginable distances, linking galaxies in a web of illumination and signaling the universe's growing complexity. The earliest star clusters had long since burned out, their remnants seeding future generations with the building blocks of planets, moons, and, eventually, life itself. Cosmic structures grew, collided, and merged in a turbulent choreography dictated by gravity and dark matter, while the echo of the primordial light, the cosmic microwave background, remained as a quiet witness, a ghostly fingerprint of creation that allows us, billions of years later, to read the universe's autobiography. Every photon from those first stars and galaxies carries a story of struggle and survival, of matter pulled from chaos into form, of light piercing darkness, and of the unending cycle of birth, death, and rebirth on a cosmic scale. Standing metaphorically in this newborn universe, one could trace the journey of every atom in our bodies to these earliest lights, connecting our existence to the first glimmers after the Big Bang. And as we peer into the heavens today, mapping distant galaxies and decoding the cosmic microwave background, we are, in essence, witnessing the universe remembering its own beginning, understanding itself through the very photons that first illuminated the void. The story of the first light is not just a tale of photons or stars. It is the awakening of the universe itself, the first whisper of existence that would echo through time and space, shaping everything to come. The first light after the Big Bang is more than a scientific phenomenon. It is the universe's grand awakening, a luminous reminder that even from chaos, structure, beauty, and life emerge. Every star, galaxy, and photon today is a descendant of that first cosmic glow, and by studying it, we peer into the very heart of creation. If you enjoyed this journey through the dawn of the cosmos, don't forget to like, share, and subscribe to Mr Galactic for more epic explorations of the universe. Also, we'd love to know, what time and where are you watching from? Every answer helps us connect with cosmic explorers like you, wherever you are in the universe.